Hi, this is Jason Baker, and welcome back to our lecture on Docker containers. I left off by talking a little bit about networking, and let's continue that discussion. Now, Docker containers have their own networking stack. You can think of them as being a completely separate, in most cases, a completely separate networking environment. And Docker containers have private IP addresses. And if you recall, those private IP addresses are not routable across the internet. So they have private IP addresses, and if you're running a service within a container, that service is going to be communicating over a particular port or set of ports. You would, if you want to be able to access that service in a container from outside of the container, either from the host or from another container running on the host, then the ports that a service is using within the container have to be exposed. Now, if you want to be able to access that container from other servers, right? So you have multiple EC2 instances, each one of which is running a set of containers. If you want a container on one host to be able to talk to a container on a different host, then the the containers must publish their ports. So, which essentially maps those ports to the host. So let me walk through this again. If you have a service running within a container and you want other containers on the same host to be able to communicate with the service running in that container, then you have to expose the port on the container. So you can set up a container running an Nginx web server, and you would expose port 80. Then any other containers running on that same host can talk to the web server on port 80. And they're all talking via this private IP network. However, if you want to be able to access that web server running in that container, if you want to be able to access it over the internet or from another system, then that container not only has to expose its port, it also has to publish the port. And it publishes that port by mapping that port to the local host. So now the local host will respond to requests on port 80, and then it will map those requests to the web server running inside the container. And the way that you map ports on a container is by when you run a container at runtime, you would specify that you want to map a port from a container. So here's an example where we are publishing the exposed ports on a container. This is a container that's using Nginx. Let's go ahead and actually maybe we'll actually just try this so you can see what's happening. I'm going to do a Docker run -d and then capital P or dash capital P Nginx. It will go download the layers to the Nginx image and then instantiate and create a new container. Now, if I do Docker PS, then you can see that, and of course, I'm running this container in detached mode. So I'm running Nginx now on a container in the background. This container now has published my port, and it's mapping port 80 in the container uh, to port 32768 on the host. Now, if I provide the dash uppercase P argument, then what will happen is Docker will just randomly pick a port on the host and map that to my container. Typically, I want to have more control than that. So typically, I want to explicitly map a port on the container. Um, let's do, if I just do a curl localhost 32.768, you'll see that it pops up with a bunch of HTML. That's my default Nginx configuration. I'm gonna stop this container here, and I want to run a new Nginx container, but this time I want to manually allocate the port on the host that will be mapped to my container port. So do a Docker run in detached mode, lowercase -p, and I'm going to map port 80 on the host to port 80 in the container. I'll run Nginx again, and I'll do Docker service or do Docker PS, and now you can see that port 80 on the host is mapped to port 80 in the container. If I do a curl localhost, it'll default to using port 80, and now you can see it's pulling up my default Nginx HTML page. You might be wondering, well, what is the actual IP address of my container? I can use the docker inspect command to find that information. And I can pass in a filter if I want to just pull out the IP address. So let me do that. First of all, let me find the image, and so C497. And so my Docker image, my Docker container is running using the IP address 172.17.0.2, which is a private IP network block. Now, when you create a container, the container can use it can use multiple networking modes, each of which is supported by a different networking driver. By default, every network or every container has a bridge mode network, which basically um, it connects the Docker container uh, to the host as a bridge, and it sets up a virtual Ethernet 0 interface on the container. You can also run the container using other networking modes. For example, you could set it up with a null networking mode, in which case the container wouldn't actually even have a network installed. You could set it up in host mode so that the container uses the same network interface as the host. So there are a variety of different networks that you can set up. We'll learn in the next lecture about the overlay network, and the overlay network allows multiple containers to communicate with one another and across multiple servers, so across multiple EC2 instances. So when you set up a network interface within Docker, you can also define Docker networks. And Docker networks are sort of virtual networks that you can use to connect different containers together. Because remember, containers are all communicating or using private network address space. So when you set up a bunch of containers on a server, you'd like those containers to be able to communicate with one another, and they do that using a virtual network. And you can look at the different networks that are installed on a Docker host by running the Docker network command. And of course, you can create new networks on a host and then associate containers with a particular network. If two containers are on the same network, then those containers will be able to communicate with one another. And we'll see some more details about uh, Docker networking in the next layer, next lecture when we talk about container orchestration. So uh, one of the challenges that you have when working with containers is trying to figure out how to persist data. Because one thing to keep in mind is that when you create a container and if you store data within the container itself, later on, if you go and delete the container, you essentially are going to delete and remove all of your data. And you might be thinking, well, that maybe that's not such a big deal because I'm going to, launch a container and I'm going to run my container for a long period of time. The reality is that containers generally don't live all that long. You might run containers in some cases for a few seconds or minutes or hours or days. They're not designed to be like long-lived. Um, they're not supposed to be long-lived like infrastructure components. They're not like EC2 instances or virtual machines. And so the best practice is that if you need to store data within your container, let's say you have like a database service that you're running in your container and you need to store and persist data, then you should store that data outside of the container so that the actual data storage is independent of the container itself. That way, if you stop and remove the container or start a new container, that the data that the container needs is actually located, outside of or independent of the container itself. And the way you do that is by specifying Docker volumes. And a Docker volume is nothing more than a directory that we specify on our local host that contains data which will be mapped into the file system of our Docker container. So for example, here's a Docker run command where we're going to spin up a new container using the Nginx image. And we're going to create a volume using the -v argument. We're going to map in the HTML directory within our home directory on our Docker host. We're going to map that directory into the user share nginx HTML directory on the container. Well, what does that mean? Well, what this means is that if you were then to access the running container and go to this user share nginx HTML directory, the contents of this directory would mirror the contents of the HTML subdirectory within your home directory. They mirror because they're literally mapped together. They're one and the same. So Docker can kind of virtually create this mapping. And this is called a bind volume mount within Docker. We can also create volumes using inside of a Docker file. So we can specify a volume mount within a Docker file. Now you got to be careful about doing this because that might make your Docker file less portable. If the container image is expecting a a if it's expecting that the container will be mapped to a directory on the host system and that directory doesn't exist on the host system, then the container deployment will fail. So I'd say as a best practice, you're generally not going to map volumes within a Docker file or within the actual container image. There might be some cases where you do that, but majority of the time you're probably not going to do that. Okay, so so we've talked about in this lecture about Docker containers. You've seen how to exercise some of the Docker client commands to start and stop a container, to get a list of running containers, see a list of images. We've also looked at Docker files. We can use Docker files to create new container images. We can then use those images to launch new containers. What you'll find is that uh, over time, you want to be able to use multiple Docker containers to deploy some sort of service, right? Because your 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 application service probably isn't going to be composed of just one service, like an Nginx web server. It's probably going to have Nginx. It might have some sort of application server. It might have a database server. Maybe it'll have a key value store. It could have a variety of different components. We can use Docker Compose to launch a set of containers together as sort of one package and one deployment. And we can use then Docker Compose to specify how each of those containers should be run and how they might be connected together. We don't use Docker Compose much in this course. That might change in the future as I add more Docker material, but I just want you to be aware of the fact that you can use Docker Compose. And again, we use it to deploy a set of containers. And usually we're deploying an entire application that consists of multiple containers. And instead of using these Docker run commands to instantiate each container manually, we can describe how those containers are run in a Docker Compose file, which is a YAML file. And because it's a YAML file, we can, of course, check it into our Git repository. We can add it to our software deployment pipelines, and it enables greater automation. The last thing I'll leave you with as part of this lecture is just a note on how to troubleshoot containers. Let's say I have a container that's running in my environment. And I think we still have this Nginx container running. Now, let's say that I'm having some problem with this container. How do I troubleshoot what's going on? How do I log into the container? Well, the container's I can't log into it using SSH because, again, this isn't a virtual machine. There's no SSH process or no SSH server running inside of the container. In order to access the container, I need to basically interactively attach to it. And I can do that using the exec command. I can run docker exec and run it interactively. I want to access this container, so I can provide the container ID or the container name. And then I specify what command I want to run. In this case, I just want to get to a shell prompt within the container. And so I execute that, and now I am inside the container. I can list around and look at what's installed. So I can now I'm essentially shelled into the container, and I can run my troubleshooting command. So docker exec, very, very useful command, and something that I use all the time when troubleshooting running containers. I mentioned earlier that when you're pulling images, oftentimes you can pull them from the Docker Hub. That's the default repository location. You can, of course, run your own Docker repository. You can create your images just like you saw me do here using Docker files in the lecture. When you create an image, you can then publish that image. You can upload it into the Docker Hub and make it available for other people. Or it can just be like a private image, which only you can access. So you can go and create an account on Docker Hub and then publish your images there. It's kind of think of it as like sort of GitHub, but for Docker images.